Alright, and let's get to some more basic stuff here too. It pretty much shows the general overall stuff of what's happening. But what I want to do is get back to specific settings in the EWSS. So what I'm going to do is, let's go ahead and pause this right here. And I'm going to move the B1B. I'm going to move him over here, and I'm actually going to kill some of these emitters because, actually, you know what, maybe we'll leave the long track. This guy's a bit more complex, so I'll remove him. And we'll kill this guy right here. So the scenario is considerably more simplified. And now we should see the long track by itself, basically. Alright, so you can see it popping up over here. And what I'm going to do here is I'm going to zoom in a little bit so we can see what's going on. And there we go. And we're now showing a signal that's coming up. So this signal is coming from the EWSS, obviously, but it's not in the EWSS. This is actually, this whole application, the MRS, is entirely separate from the EWSS. So it's really just sort of harvesting the data. Alright, so what I'm going to do here is, in fact, another way of doing this is to take that guy back to there. And what I'm going to do is go ahead and adjust the properties at the same time that we have a signal analysis up so that we can see the long track. And we'll go ahead and do this. And let's turn everything back on here. Okay, so now to show you how we can change everything during runtime. We're paused, but it doesn't really matter. I just don't want the platforms to move at the moment. I'm going to go ahead and change things in the long track itself. And I'm going to turn this up a little bit so you can hear the audio again. And I'll change this to 6, slow them down a little bit. And I'm going to go ahead and edit the beam shape and give it some side lobes. This thing is a little laggy, and it's because of this recording system we're using. But there we go. Okay, we now have a side lobe, and what I'm going to do is give him a little bit more of a omni in that direction. Now in this view here you can see what the beam shape actually looks like. And now you can see the side lobe that we went ahead and created. And you should be able to hear the audio here. Now, that's just beam. I can also change the signal itself. So we'll change the signal, and now you should hear a much higher pitch. Okay, and now we'll go back. Alright, so that's the basics of the EWSS and some of the advanced features as well, and really gives you an idea of what's going on in the scenario. One other thing I wanted to show you. I want to show you the attenuation region. So let me go go here to the signal analysis, and this time I'm not going to change the power. And his side lobe, the side lobe is not represented here, but his side lobe still exists, and so that's what's popping up over there. Alright, so you can see the relative power here. Now, for the attenuation to region to work, I'm going to have to go ahead and give him a bit higher frequency, because low frequencies aren't affected by rainfall that much. Okay, so change it to a higher frequency, and now as you watch, in fact, one other thing I want to do. Let's go ahead and make his beam really large so you can actually see what's... Okay. And his side lobes. Let's change that to... let's make it only 15. Okay. And let's take a look at what's going on here. Oh, actually, here's a problem. What we need to do is change it back to sin x over x. That gives us the basic beam shape. Once you begin editing it and you get a custom beam shape, then you are forever a custom beam shape. You can't use the side lobes value or the beam width value anymore. So now it's a custom beam shape. So I could change these beam widths and side lobes. That won't make any difference here unless I start over again. Okay. Okay, here's our very weird looking beam shape. And I'll go back to signal analysis. And we'll see the beam come by. Alright. And now I'll show you how things are affected in real time. So even as I move this B1B around, this model around, you can see that everything is changing just as I do it. In fact, it can be even playing, doesn't make any difference. B1B will try and run away, but I'm just going to move it. And you'll see as I'm in the attenuation region, it's barely picked up at all. And those side lobes are kicking in again. And if I move out of the attenuation region, we should get a much stronger signal. Now, it's on log scale. Let's go ahead and exaggerate this a little bit so that we have gigahertz. Move this guy up to here, and I'll move this one up to here. Must be another point down there. Okay. So this is appropriate. Okay. And my B1B is running around out here. Let me just move him. And I move him into the attenuation region, and now you can clearly see that there is a large attenuation due to the rainfall. Now as I move it throughout the attenuation region, there's less attenuation region. You can see it becomes less and less effective, which is what makes sense. Okay, that's pretty much a full tour of the EWSS. And there are many more controls and values that I haven't touched on. In fact, I haven't even touched on the joining of two scenarios together, which you can do over the network. Two or more scenarios, in fact. You can have a whole classroom of scenarios that are joined together in a peer-to-peer system. But that's a bit beyond the scope of this video. So I hope you enjoyed learning about the EWSS. And in the next video, we'll talk a bit more about the MRS system.